I wonder if hagfish, are they related to lampreys? They have that same...
Bridge, this is Nav, another step, please.
No.
Okay, so we're done with our survey?
Yeah. Yeah.
Righto.
We keep moving.
Yep.
Bridge, this is Nav, another step.
Is that a coral up there on the rock? That little guy?
Yeah, it looks like it.
Zoom in it.
Anemone behind him.
And a cup coral.
Oh yeah. That's a really pretty coral. It looks so smooth, doesn't it?
It is.
There's a little hermit crab in the bottom right.
Bridge, this is Nav, another step.
Is that another coral over there? Or a sponge maybe? Those white stalk or tall stalks?
Looks like a coral.
Bamboo.
Bamboo.
Looks like a bamboo, yeah.
Bridge, this is
Zoom
Nav,
in
another
again,
step,
Ed.
please.
Zoom. We zoom in on the base.
It's where it's got like one dead, inactive branch down.
I think it is a bamboo.
Yeah, I see the banding.
Yeah. Alright.
It's weird, there's a band right after that branch, and normally you would see the band before the branch. But that's a method of identification. Let's take a closer look.
Now that you mention it.
Bridge, this is Nav, another step.
Pretty.
Yeah, it's really pretty.
Pretty.
That's a full zoom. Let me come out a bit, get you a little more of the organism.
Pretty.
Okay.
Coming out.
And we're off.
Bridge, this is nav, another step.
And we're off.
Ooh, there's a big sponge.
Oh, what now? Big sponge off to the right.
Here.
See it in
That whole
August.
thing?
August.
It's cool to look at the Argus cam and you can see how big they are in comparison.
It's really cool when we find the giant fan corals and they're the size of Herc.
Oh yeah.
There's another one that's stalked.
Yeah. Can see it creeping in. Those are pretty ones. They look like big flowers.
Bridge, this is nav, another step, please.
A bird bath.
No.
Bridge, this is nav, another step, please.
Alright, looks like we have something coming up in the distance. Coral, maybe?
Looks like a sponge.
A sponge? Another big one. Lots of big
Yeah,
sponges.
it's very big.
Oh, that's cool.
Really? Zoom in on that.
Zoom in, Ed.
Coming in.
Kind of at the end of our rope, but
Bridge, this is nav,
There's a squat
another step,
It's
please.
a big squat.
flashing the old gang sign, C for crustacean.
Oh, pretty. Looks so fluffy.
Bridge, this is nav. Another step, please.
Okay, thank you.
That's a cool shot. I like that.
I keep the move, so
Zoom in again, Ed. What's this down in there?
Oh,
Shell fragments, dead squat.
Oh, yeah.
Bridge, this is nav. Another step, please.
Or he could have molted. It's
Oh, yeah.
squat
oh
molting.
yeah. That's a good point.
All right, moving on. You're gonna get
Moving on.
fall behind here.
Scoot, scoot. Is that a different species of sponge behind it too? That big
Can't see.
bulky one?
Quick zoom.
That one looks like the one we slurped.
Yeah,
Mhm.
sponge again.
Spongy sponge.
Sponges. Sponges among us.
Does anything eat sponges? Or do they just live in peace and harmony with squat lobsters?
No, don't turtles eat sponges? No, they eat jellyfish.
Jellyfish.
They eat jellyfish.
I don't know.
Let's find out, shall we? Oops. What?
Looks like a pretty tall out in front.
Oh, there's such a thing as meat-eating sponges. I didn't know that. Did you?
I've heard of it, but I've never actually seen one.
Oh, we're gonna get into
Whoa.
Whoa!
sponge land.
Yay!
Sponge land.
We have arrived. Cool.
Do we want to pop a Niskin here,
Oh,
Chris?
maybe.
Yeah,
Sure.
Yeah.
yeah.
So, Alyssa, could I get you to turn? Oh, maybe you're way ahead of me. Look at you.
Look at that. Only took a few weeks.
Yeah. Yeah. Last day. Got it. You want to rack me back,
Racking back,
please?
maybe.
I'm going to blow out your shot to give you a view of these things, too. Huh.
Rocker. Rocker.
There we go.
So we haven't taken one yet, right?
Nope.
No, they're all open.
We all watching? Everybody watching?
I'm watching.
going
You're
for
doing the
12?
front one?
Oh, are we doing the back, front, back?
It doesn't matter.
You know, I'd like to start from the back because then it's easier to see. Hold on a sec. Let me give you some gain. Is that helpful?
Yeah.
Cool.
Come on. Get in the hole.
There you go.
dang thing.
That'll work.
Nice one.
I'm watching.
Oh.
Not yet.
His loops are all squished down so you can't get a finger in them. Get it. Come on.
There you go.
Yes.
Just
Nailed
got
it.
triggered.
Triggered.
Cool.
Yep.
Thank you.
Sweet. So if you're just watching, that is a Niskin sample. So those little tubes in the feed 3 that you just saw suck in a bunch of water, and then that goes into the wet lab where the science team can conduct eDNA analysis, so environmental DNA analysis, and sort of determine why an area like this all of a sudden has a bunch of sponges, for example. Was Niskin the person that invented the bottles? Do we know?
I defer.
We defer?
I think Nansen, actually, the original bottles were called Nansen bottles
Yeah.
for Frigid Nansen, who was a Norwegian explorer who did all kinds of neat stuff.
Oh, yep. Okay, so it was first developed by Nansen and then further developed by Shale Niskin.
Yeah. But yeah, Nansen was a cool guy.
Why was he cool?
He went all over the place and he has a whole bunch of firsts to his name. He was a big Arctic guy, went to the Antarctic as well. Frigid, it's a Norwegian name though.
Fridtjof?
Yeah, but if you Google him real fast, he did some cool stuff.
Whoa,
Bridge, this
he
is
looks
Nav.
like a serious
Another
dude.
step,
Yeah,
please.
he's like, don't mess around with this guy. It's like,
Yeah.
I'll eat you for breakfast.
Yeah. So he was alive between 1861 and 1930.
So he was neat for one thing, is that he made a observation. He was an Arctic guy. He made the observation that icebergs don't go downwind when they drift.
Hmm.
They go sideways to the wind, which is not obvious, like counterintuitive.
Yeah. Why is that?
Because I'll tell you.
Oh.
And then he had a friend named Ekman who was a student of his, and Ekman was a mathematician. And Ekman figured out the Coriolis effect, which pushes water to the side of where it should be going, so to speak. And if you aggregate that effect down through the water column, you get something called an Ekman spiral, where the net transport of water in the surface ocean is actually at a right angle to the wind. And it's the net transport that actually pushes icebergs to the right.
Bridge,
Huh.
this is Nav.
And so the way it works is
Another step,
it's a
please.
Coriolis effect. So since we live on a rotating planet, if you have a steady force pushing something that's relatively frictionless, meaning not nailed to the floor or the bottom, right, to the earth spins, so to speak, underneath of it, and that's creates not straight line motion, so to speak, as observed in the Earth's reference frame.
Huh.
And so this happens in ocean currents, right? So the wind pushes the water, but the water can't. Eventually we'll get, basically you can think about the Earth spinning under the water. And if you're on the Earth's reference frame, it looks as if the water is moving, not the direction the wind has been pushing it. So that's fact one. And fact two is that the ocean is like a stack of pancakes. There's layers of water, and the wind pushes the first pancake, the top pancake, so to speak, and it gets pushed off to the right of the wind due to the Coriolis effect. That water, that pancake, pushes the pancake underneath of it to the right of the first pancake's direction.
Hmm.
And the third pancake is pushed by the second pancake to the right of the second pancake's direction. And so each sixth pancake as you go down the stack
it'll
is
be moving
pushed to the
towards
right of
south.
the one above it. And so
South?
it creates a
South.
spiral
Okay.
effect.
180.
And if you average the direction of all the pancakes, you get a the average is to the right. And so that's the net transport of water. And so Nansen and his buddy mathematician Ekman figured that out. Nansen's observation and then Ekman described the mathematics behind it.
Don't start
And that's
coming up
pretty cool.
before I
Ekman
make the move, or do you think it will be
So if you
fine?
just Google Ekman spiral with a K, E,
Don't to come up
you'll see a picture of it.
a little bit? Or do you
It's
think
crazy
we'll be
that it
fine
also just
starting
took
the
one
move?
person
You
to
can start to
see
move.
that and be like, huh, that doesn't really look like
Chris?
it should.
Yep, go ahead.
We'll be starting going more to south
Sure.
till we get to here. Bridge, this is nav. The next move will be on bearing 180, 10 meters, please.
Here they come.
Oh, the corals and sponges. Oh, those are all just sponges, huh?
It's the red thing.
That's a crinoid or a, I think it's a crinoid on there.
Huh?
Want to zoom in, Ed?
Yeah, coming in. The crinoid, that red
Yeah,
right
it is.
there.
It is a crinoid.
Yeah, that's
Yep.
Looks like a bristle brush. Looks like a pine tree branch, like a Christmas tree wreath.
And coming out. Squad associate.
Is this Coriolis effect?
Bridge, this is nav.
Is
Another
this
step, please.
Does this sort of explain the maps that we were looking at yesterday when you look out from the beach and you see that other beach?
No, that's totally, yeah, that's
totally different.
that's just plain old geometry, just going around the Earth. The
From beach to beach.
the beach to beach thing. The Coriolis is a dynamics thing.
Hmm.
And so the way to think about the Coriolis effect is if I have a record player, right, sitting in front of me, and it's spinning. Imagine that the Earth is the record,
Okay.
and we live on the record, right? So everything you've ever known in your life is walking around on that record, and you don't sort of realize that you're actually spinning. Everything to you on the record looks like it should, like stationary, right? Because you and the record are going at the same kind of angular velocity, right? And so that's like you on the Earth. The spin is quite slow, so you don't feel it. But if you're standing on the record player, looking at the record, it looks like a static scene, right? That makes sense?
Yeah.
Now let's say someone rolls a ball across the record as it's spinning, right, from outside. And they just push it and a ball rolls across the record. From the person who rolled the ball's perspective, not on the record, they rolled the ball in a straight line right across the record.
Uh-huh.
And they saw the ball go in a straight line. You, standing on the record, what did you see?
So it moved to
The ball would actually trace out, as it was going across the record, a curved path,
Mm-hmm.
right? So like you have a mouse pad in front of you, you know, and you have the computer, a piece of paper, move your hand in a straight line and simultaneously spin the
Bridge, this is
paper,
nav. Another step,
you draw a
please.
curve on the paper.
Right, right.
So if you are living on the record player and that ball rolls by, what are you going to see? You're going to see the ball rolling in a curved path, right? You will not observe it going in a straight line. You will observe it going in an arc. And you'd have to think to yourself, huh, that's weird. Why would it have curved, right?
Right.
Because everything else that you're looking at on the record player that's static is not curving. Except that ball that just rolled by in an arc, not a straight line to you. And so the Coriolis is a thing, it's a made-up force that we use to make the math work out to describe that curve that the ball made. Does it make sense?
Yeah.
Zoom in the fish.
Yeah, it totally does actually. I
Say
mean,
again?
in the very
Zoom in fish.
Got it. Bump.
Yeah, it looks like a cuskeel.
Yeah, the Coriolis is a slippery thing to sort of wrap your head around.
Yeah.
But
I mean, that very basic explanation.
right.
If I think about it too much, I'll
Bridge,
probably
this
get
is-
lost.
Nav,
Well, another
step,
way to
please.
think about it is if I was standing at the equator and I threw a football toward the North Pole, right?
Hmm.
Straight up north. And after I let go of that football, it's not fixed to the earth anymore, right? It's floating above the earth.
Right.
As it's traveling toward the North Pole, the earth is spinning underneath of it. So what is the football going to land on the line that went from you to the North Pole?
No.
No. The earth's going to spin out of its way and it's going to land not on that line. And you need now a way to describe that motion,
Right, right.
right? Because you're like, well, I just threw the stupid ball at the North Pole. Like, why did it land over there? Right? It's because as it was detached from the Earth moved. And the path it would have followed if you followed its shadow on the ground would be a curve. And so that's so winds and ocean currents move around relatively free from the friction of the earth.
Hmm.
And so they travel in these curved paths that the football is traveling on,
So it helps
not
us
in a straight line.
also predict sort of weather patterns and different.
Yeah, the whole reason we have
Uh-huh.
the wind patterns we have on Earth is because of Coriolis. Actually, the reasons we have the winds we have right now, these trade winds have been blowing
Mm-hmm.
steady, super steady, for weeks on end down here in the same direction. That's because
Bridge, this is Nav,
Coriolis
another
effect.
step, please.
the air is trying to get to the equator and rise up because it's warm. So it's running from south of us, trying to get to the equator, which is north of us, and rise up because that's warm. But it can't actually get there. It's trying to, but it's actually being bent off course by the Coriolis, and that makes the trade winds that blow steadily around here from the east to the west.
Huh. I feel like I just had a physics lesson too.
Me too. I was trying to figure out what part of this was going to be on the test, and
Yeah.
how do I keep track of it? What's the mnemonic I'm going to use to remember this?
Yeah, that's
I
super
like the
interesting.
record player analogy, though. That's very effective.
And the pancakes too, for the Ekman effect.
Yeah, I go over some of this in the class I teach, and it's a slippery topic. Some people just get it right away. Other people you can explain till you're blue in the face.
Yeah.
So is the right angle effect in the fluid reproducible in lab?
Yep. So people have what are called
Bridge, this is
rotating
Nav, another
tables.
step, please.
And so GSO has one, Woods Hole has a bunch of them. Some friends I have that do experiments on these, and what you do is if you want to simulate large-scale ocean currents, you do it in scale form, and you get a tank that rotates. So it might be something the size of a kiddie pool, and it's on a big rotating table, like a big giant record player, actually, right? And then you can get that thing going, and it's moving fast relative to the actual Earth. And so you can do mini
15
experiments.
degrees every hour, is that right?
That's what the Earth spins, 15
Yeah.
degrees an hour. So so people do all kinds of, they're called rotating table experiments, but they put dye in the water, and you can look at the way
And you see. Yeah.
vortices interact with each other, and you can sort of
Wow.
simulate
Cool.
large-scale physical flows in the lab. Yeah, if you just Google like rotating table oceanography, you'll see pictures of these things, and the dye experiments are pretty cool.
Chris, did you ever hear the commencement address that Steve Jobs delivered at Stanford?
I don't think so.
There's a great part in there where he talks about
Bridge, this is Nav, another step, please.
dropping out of Reed College in Portland, Oregon, and how that was a liberating experience because then he just started taking a ton of classes that he was just interested in and just sitting in and learning and not being bound to the, multi-year progression. So you could drop in a Physics 301 or whatever.
Yeah, that'd be neat. It'd be nice to do that.
And that was pre-TED Talk days.
Yeah, the class I teach is a gen ed, not science majors, and so you get some people there just taking it for the all people are taking it for the sake of ticking a box, but some people really do well in it.
One of the PIs that Allison and I worked with in another life is teaching a class now on the ocean and the arts, and how you find, and maybe it's the ocean and mankind, like how it affects economies and where you find it in poetry and literature.
Yeah, that'd be fun. Yeah.
Migration.
Who is that?
John Delaney.
Oh, yeah. I know John a little bit.
No surprise there, huh?
Yeah. I taught a class for a year at GSO, which was I called Sailing the Blue Planet, and I just went over all the physics that explain sailboats, windsurfing, surfing, and why do we have sea breezes, and this basic coastal weather if you're a sailor or a surfer. I went over wave mechanics, or if you're a windsurfer or whatever, diver. Like, it just was kind of what are the physics that govern this water sports. It was kind of fun.
That's really cool.
Yeah, I wish I had that kind of a class.
Yeah, it was neat. I don't know why I haven't taught it in a long time. I just got busy teaching other things, but it was a fun class. It was just sort of
Bridge, this is now another step.
for that Coriolis stuff. I made some movies with a what are those little Nerf guns?
Yeah.
Shoot a little like 3-inch long foam Nerf thing. And so I made some movies of me spinning around. And I took a Nerf gun and tied it to taped it to a broomstick and like spun and shot. And I had my iPhone, my phone at the back of the Nerf gun in slow-mo mode, so you could see the Nerf bullet coming out, and you could see the broomstick sweeping, and you'd swear on that video that you saw the Nerf bullet curve, right? And that illustrates the Coriolis effect. And then I did other ones where I held the broomstick and the gun was out from me, kind of whipping around, right? So I'm at the center now, and I'm holding the broomstick, and the gun is on the far end of the broomstick, pointing back at me. That's sort of like I'm the North Pole,
right?
Shooting a projectile, or like throwing that football from the equator to the North Pole. And I tied a string around the trigger on the gun, and I pull it, and I videoed it both ways, and so like you get a picture of me shooting myself with this.
Are these on YouTube?
No, they're just on my laptop. It's kind of neat.
Do you remember
Yeah.
I think he was a German-born professor of physics at MIT, whose classes were broadcast like 20 years ago.
Until
I'm trying to remember.
August come back very close. Everything I think we are
What
getting
is
to
the
the
name? I
wall.
know who you're talking about.
But he did a lot of
Because the
in-class
difference
experiments
in-
with that. But
Talking about the mechanical universe?
maybe he would ask students in advance, I'm going to release this pendulum, what's going to happen when it gets over here, and
Oh yeah, I saw
everybody would
that
come up
one.
with
It's about
theories, and then he
70
would do
meters
it.
up from here to here.
Yeah, I remember. Who
7-0.
was that guy? I remember that. There was another person, Woody. Somebody was a professor of mechanical engineering or electrical engineering when I was there, and who was quite a lecturer, and his classes were always packed. Everybody wanted to go to his lectures. I have the names I'm forgetting now. But
Yeah, Mechanical Universe was on PBS for a long time. There's probably 100 episodes.
Well,
or
yeah.
something. He talked about the history of physics.
yeah, I try and make my class I usually try and bring in something most classes. Some object, something to pass around, some little experiment to do, something.
To make it more tangible.
Yeah.
Yeah.
The thing I like bringing in is a Rubens tube. Google Rubens tube, and you'll see what that is. R-U-E-B-E-N-S, Rubens tube.
Like a Reuben sandwich.
Yeah. Wait,
Oh no,
take a look at
she's
what a
hungry
Rubens.
again.
Yeah.
We're doomed.
But take a look at a Rubens tube, and then make sure you have a picture of one.
Well, Mechanical Universe is at Caltech, though. That's right.
Okay, I can see this, the Rubens flame tube.
Yeah, I have one of those. I built one.
Oh, cool.
I bring that into school. That's how you talk about acoustics. You play a sound in the end, and the wavy flames actually are a visualization of the sound wave passing through the tube.
Whoa. Didn't they make, I feel like there was an exhibit somewhere where they made like a giant one of these and that you could sort of walk through and the sound, and then using different.
Maybe I went to Maker Faire a while ago, and there was a display that had a whole mess of Rubens tubes in a big box. And they were playing music, and you could see the flames dancing all over the place. Basically, it's like a flame equalizer. It's pretty cool. I made one of these. I have it at home. I bring it into class.
And how do you play music in it? You just like stick an iPod in there?
Yeah, there's a
Mushroom
speaker you
coral.
stick in the end.
Zoom in.
Yeah.
And then I
Yeah.
just use my phone, and I have a frequency generator. I can generate pure tones, and you can make the sine waves.
That's
make the
super
waves.
cool.
Oh, that's that thing that
It's
we were
the
trying to
mushroom
find.
coral, yeah.
Yeah.
The mushroom coral.
We saw that
Yeah.
last night too, right?
We were trying to get one last night. We didn't.
A lot of cup coral.
Yeah, I was going to say a whole mess of cup
Oh,
corals.
do we want this?
Do we want that guy? We were trying to get one the other night.
Do we have to take the whole thing? How big is it?
It's pretty small. Pretty small. There's another one up. There's
there?
another one above it. It might be easier. Or maybe not. There's a whole mess of cup corals here. So I don't know how. I have no sense of how easy that thing is going to be to snip. I think it's a lot
Snip?
small. I think it's a lot smaller than the jaws.
Yeah.
Can we put lasers on it?
Well, maybe not.
Dang it. It's not a very good spot to set up
There's
on.
one above it.
There are more.
Right? No, is that? No, that's a. Oh yeah, see that one
No,
over
I
there,
saw
and
that,
like
yeah.
on the kind of on the other side of the rock.
Yeah.
I don't know if you pivot around, if that'll be any easier. That guy, it's a little more
Yeah.
open. It's not as much of a
That's
hole.
better.
Yeah.
So precarious ledges here.
Yeah, this is much better.
Yeah.
I don't know about much better. somewhat better.
It's still not super great.
An improvement.
So we going for it?
I'd like to know how big this is.
Well, why
If-
don't we
if we
just
can
get the manipulator over there and then
Okay.
you can
Yeah.
Okay.
For scale.
You think it's slurpable?
It's bigger than the slurp, but it's, you know, if you're gonna be able to break off a piece, because it might just squash with the coral cutter. Well, let's see.
Yeah.
You see how big it is?
Yeah. How would you take that?
I can snip some.
Yeah, let's do that. Snip and then slurp?
Yeah,
Okay.
snip and slurp.
Snip and slurp. Sounds good.
Snurp.
Slurp. Are we on chamber 2?
Ah,
Yeah, I think we are.
I can't.
We only slurped the one white sponge, right?
Yes.
We're on chamber
Not
2 right now.
tell. I don't think you have anything in there.
Oh. Maybe?
Or
It goes.
had might be appropriate. Because there's a space between the Tygon and the knives that little things get stuck. So we're just giving it a little haircut.
Hard to see in there.
Yeah.
Well, there's definitely something in there
Yeah.
now.
Good.
Ooh, nice.
Can you zoom in, Ed?
Slurp coming on.
Alright, you can see our slurp chambers. Sat feed 3 if you're in the quad.
Do you want us to get in a bucket for you, Bob? Or, I'm sorry, Bubble. Oh, there we
Wow,
go.
nice shot.
Watching.
And survey says.
Still slurping, right?
Boom.
There
it's
we go.
Oh, is he
Okay.
stuck?
It's a duck?
Is
What?
it duck?
What happened?
It's. I think it's in there. It's just stuck
I think it's
on
immediately stuck on the,
on the
on the
filter.
tank. Okay, so yeah, kill the suction.
That
then.
was an effective slurp.
You can turn
And then
off
there's
the
also
suction.
there's some there was some sponge bits in
Sponge
there
in
as
there
well
and the-
from last time.
They were already in there, yeah. All right,
Did we
back
run
to Bob.
the flush after we did all that operation before?
Yeah, we
Oh, we
did.
did.
We did, but I guess
Yeah.
something that was still in there.
You gonna run flush again?
Sure.
Oh yeah, you got it. See that frame right there? It was all stuck on the mesh immediately.
Suna, you said you think this is a mushroom coral?
Yeah, it's an Anthemastus mushroom coral.
Hey, moving on.
Moving
Yep.
on. Actually, well, while we're sitting down here, there's no rocks to be had. I haven't seen a grabbable rock in a long time.
So be on the lookout for
Yeah,
rocks.
I think maybe it might be time for another rock just based on depth stratification. But I haven't seen a grabbable one in a while. We've had these big macro scale flows. Like that's not saying grabbable rock.
No. Not so much.
We don't have a whole lot of tether.
Where's the next sponge?
Stingy with that stuff.
Some crinoids on top.
You keep running away from me.
We have lasers on that guy. How big is that thing?
Whoa.
Pew pew.
There you go.
Pew. Whoa.
Bigger
Okay.
than 10 centimeters.
Okay, that's
20,
pretty.
30, 40, 50, 60.
Yeah, that's,
Can
that's
see
like a
it.
bushel basket
Argus
size.
cam, yeah. That thing is huge.
A peck.
A bushel and a peck.
Bridge, this is Nav. Another step, please.
Is that a sponge on top of it?
I think it's on
Carnoid.
the, it's
It
on
looks
the
like
side.
a stalk
It's
sponge
stalked
behind
over.
it.
Oh,
It's just
behind it.
Off to the right.
It's laying over. It's being lazy.
See it?
Yep, yep, yep.
Wow, this is a surreal landscape.
Right here.
Did Alyssa fall behind again? We waiting for her to catch up?
Yeah.
Yep.
Always waiting.
I feel like I'm walking my dog.
Yeah.
Naked on the leash.
That is a cool coral.
What is it? Oh.
I mean sponge.
What is that? Is it a sponge on the side of the wall? The same color as the
What are you
tether?
looking at? What you
Argus
looking at?
cam.
Oh,
Oh,
yeah.
it's the laser line.
Oh.
Oh, okay. Man.
That had me freaked out for a minute.
I know. I was looking at that like, is that the recovery line? Is that?
Yeah.
What
that's
is
what
that?
is. All right.
180.
Laser eye.
What's our depth now? What are we at?
About 700 meters.
Cool.
We're about 8 meters above the surface of the water.
Oh, like us
Yeah.
physically?
Coral, what's over here? The great blue beyond. Big
What
old
are all
ball.
those? Corals?
Yep. And
Old
some cup
attachments.
corals, old attachments.
Interesting that that side of the rock is so much darker.
Bridge, this is now another
So
step.
sedimented,
please.
top's all
Can-
sedimented.
Can you
Oh, gotcha.
look a little closer?
There's a stalked
This is
anemone down at the
zooms-
bottom of there.
Yeah, I think so.
So, Bob, you grew up in Southern California. In addition to the cool physics stuff you saw on television, did you ever see Gene Scott?
Gene Scott. That sounds-
Reverend Gene Scott, cowboy boots, recliner. No. Disregard.
What's that stalky guy down there? Right below the
Yeah.
lasers about? See him faint, purpley, pinkish.
Zoom in.
Yeah. Just to the left there.
Straight down, right at the bottom of the screen right now.
Oh, it looks like an anemone.
It's a little different in shape. I don't think we've seen too many of those
That
guys.
guy?
Yeah.
Yeah,
Is
looks
that
like
the other one that we're looking for there tonight?
No, that was a sponge. That looks like an anemone.
We haven't seen many of these guys.
No.
That's a cool. Whoa. You think that's an anemone?
Yeah.
Looks like it, yeah.
Yeah.
Weird. Little tiny corals there. See them? Oh, look like like pine branches.
That is a. It looks like there's a brain in the middle of it.
Looks like a flower.
Cup corals.
That's
Yes.
a cool one. Wow.
Hermit crab there.
It does look
Yeah.
like a flower. You're right.
That's cool. Yeah, let's jump right in there.
Little camera bounce.
Whoa, that was really neat.
All right. Moving on. Full wide. What's the... This is definitely fresher.
Ooh,
this is
big.
less manganese here.
Squat lobster over there.
All kinds of stuff here. Oh, big spiky urchin thing. What is that?
Oh yeah, huh.
Spiky snowball.
Zoom in.
There's two of them, it looks like. Urchins?
Pile of urchins.
What urchins?
Pile of them.
I thought you were gonna.
Pile of urchins.
Those are pretty. I like
Good
those
ID.
ones.
Those are weird. We haven't seen those before.
Pilo urchins.
Whoa. Get poked.
Hey, zoom out again.
Bridge, this is Nav. Another
That's
step,
a
please.
big crinoid right there.
That's my herky jerky. My Z-bias went away. That's why I was having a hard time.
Wait, are you negative?
Oh, because
We
when we did the
reset.
reset, I
Yeah.
didn't reset the Z-bias. It went away.
That's why
So
you're
I've been
dancing
having
around?
to, yeah, so I'm just trying
Having to
fight
fly it
that.
down.
Yeah. That's hard. So I can do better now. See how nice it is now?
Yeah.
I'm trying to fight the offset. Yeah. Alright.
Yeah, I've seen
Yeah.
someone who says that was a hydrozoan, not
Bridge,
a
this is
sea
Nav. Another step,
anemone.
please.
anemone.
Oh, that's why I can't find it.
Interesting. I didn't know that they were anchored though.
Hydrozone. I don't know.
Alright, big rock.
We on top? Oh yeah.
Somehow we ended
Bridge,
up
this
on the
is Nav.
moon.
Another step.
Right? It was very lunar looking. So there's landscape. When you're underwater, you say seascape. When you're on the moon, you call it a moonscape. Does every planet, so then is it a Marsscape?
Is there a Europascape?
A Jupiterscape? Marscape. I don't know if I've heard Marscape.
Sounds legit to me.
Yeah.
Said it sounds legit?
Yeah.
Yeah, I'll go with it.
Get the little
Hydrozoan Other Okeanos Guide. We have a link for it. Let's check it out.
Bridge, this
I
is
think
Nav, another
he's
step,
right, or
please.
she, whoever wrote in. It was a hydrozone.
Cool.
Thank you.
Yeah, thank you. Yep, that's totally what it looks like, huh?
Yeah.
Cool.
Bridge, this is Nav, another step, please.
Wow, these hydrozoans are really cool. I just got lost in this ID guide.
There's a big fish coming right at us. What is that? Pan down?
Ooh,
Or
look
it's a
at
shadow? Is that a shadow?
Nope,
or a
it's
fish?
definitely swimming.
That's there.
Ooh.
It's a shark.
Give me a bump up.
It is a shark.
Shark, shark, shark.
What is that?
It's not a baby.
Not a baby.
Is that a
Is it
six-bill?
a
It's like a
six-bill?
sturgeon or something.
Can't see.
So Georgia was saying, oh, hey, buddy, that the one that they saw last night, which also kind of looks like this, resembles a six-gill, but six-gills don't have two dorsal fins. Hi.
Ooh.
Oh,
Oops, sorry,
ouch.
buddy. We got you trapped.
Sorry.
There you go.
Beautiful. Oh my gosh.
Yep, still stuck.
No, we got you trapped again.
Oh,
We'll let you out of here.
Is he okay?
oh wow. Happy Shark Week, guys. He's big too, huh?
Yeah. Tail's a little worse for the wear.
I didn't do it.
Wasn't us.
He's like kind
Can I
of
get a push on you,
speckled.
Melissa?
Yep.
Might need a little tilt up. Partial on Argus.
Zoom on me too?
Got little spots.
Yeah.
Can you zoom on me too?
On what?
Zoom on me?
I can't hear you, Bob. I hear you saying zoom.
I can't mess with my microphone and drive at
Okay.
the same time.
Got it.